A much simpler and cleaner solution to the limitations of 32-bit addresses is to use much larger addresses. IPv6 uses 128-bit addresses instead of 32-bit addresses, so instead of an IPv4 address that looks like this, 4 numbers that are written in decimal separated by dots, we have numbers like this, 8 numbers that are written in hexadecimal separated by colons. So each of the parts between the colon is a 16-bit number, and then we have 8 of those, so that's 128 bits. These numbers get very long, and the address space is so vast we can't use most of it, so there are conventions to write these numbers shorter. If you have a sequence of zeros in a row like this, you can just drop them. You can only do that once though, and that's how you know how many zeros to fill back in when you decode the address. Another simplification is that for an individual number, leading zeros can be dropped. You have to have at least one digit in that number, but if there's zeros at the front, you can drop them. So this shortened form is the same as the number that was written there before. You will often see the IPv6 address : 1. That's actually 7 zeros followed by 001. And this address is used in the same way that the IPv4 127.0.0.1 address is used. It refers to the loopback device. In a world with both IPv4 and IPv6 addresses, when you resolve a name to an address, you need to say what kind of address you want. We've been using dig with a name and not specifying what kind we want. We just looked at the right part of the record. But if you want to be explicit, you can give dig an A in the same place that we wrote mx sometime. A just means get me the IPv4 address. And so for www.google.com, you might get a number like this. If you want an IPv6 address, which is 4 times as big as an IPv4, the name of that record is 4 A's in a row. So if we look up Google with 4 A's, then we would get an IPv6 address instead of an IPv4 address. When we used MX here instead of A or AAA, we usually got a name back instead of an address, and then you can take that name and map that to IPv4 or IPv6, whichever one you want. That's why most other kinds of dig queries give you names back and not numbers, so that you can do another step to get the right kind of number.